December 18th, 1944, 14:20 hours. A King Tiger from SS Schwere Panzer. Abteilung 501 is sitting at a road junction outside Stavelot, Belgium. Its 88mm KWK 43 gun covering 2,000 meters of approach road. The tank weighs 68.5 tons. Its turret front is 185mm of hardened steel. Its hull glacis is 150mm at 50 degrees, an effective thickness approaching 230mm when the angle of impact is factored in. At this road junction, in December 1944, there is no Allied ground weapon that can threaten it from the front at any combat range except one. That weapon is an M36 Jackson tank destroyer, sitting hull down behind a stone farmhouse 400 meters away. Its 90mm M3 gun loaded with a T-33 HVAP round whose tungsten carbide penetrator was not designed to defeat tank armor. It was designed to shoot down aircraft. What happens in the next 4 seconds will determine whether the King Tiger continues its advance toward the Meuse River or ends its war at this road junction. The M36's commander has one shot at the angle he has. The King Tiger's crew does not know the M36 is there. The farmhouse has been chosen specifically because it sits in the dead angle of the King Tiger's commander's cupola vision, in a position from which the M36's muzzle blast will be masked by the stone wall until the moment the round leaves the barrel. The gunner fires. The HVAP round covers 400 meters in approximately 0.5 seconds. It strikes the King Tiger's lower hull plate at an angle that produces a favorable impact geometry, less oblique than the glacis above it, slightly thinner in the specific production batch this particular King Tiger came from. The tungsten penetrator, moving at 1,021 meters per second at the muzzle and still traveling at approximately 900 meters per second at 400 meters, punches through the lower hull and detonates inside. The King Tiger burns. The M36 is already reversing behind the farmhouse. What happened in those 4 seconds was not luck, and it was not the product of a specific genius that the M36's crew possessed beyond their German counterparts. It was the result of a chain of decisions that began not in a tank design office, but in an anti-aircraft artillery program that ran through a specific wartime metallurgical discovery about tungsten, and that culminated in a tactical doctrine developed by men who had spent months thinking about what it actually meant to fight a vehicle that no American tank gun could touch at normal combat ranges. The King Tiger had been designed to be unkillable from the front. The M36's designers had not set out to build a King Tiger killer. The connection between those two facts is the unexpected part. The Panzerkampfwagen 6. Ausführung B, designated the Tiger II by Allied forces and known to German crews as the Königstiger, the King Tiger, was the product of a German engineering philosophy that had learned from the Tiger I's experience and concluded that the answer to increasing Allied firepower was more armor, applied more extensively, at better angles, to a larger vehicle. The Tiger I's 100mm frontal armor, which had seemed impenetrable when the tank entered service in 1942, had proven less absolute than anticipated as Allied anti-tank weapons improved. The King Tiger's designers at Henschel addressed this by increasing the hull front to 150mm at 50 degrees, producing an effective resistance against perpendicular projectiles equivalent to approximately 230mm of vertical plate, and the turret front to 185mm. They paired this with the 88mm KWK 43L/71, a gun whose ballistic performance exceeded that of any Allied tank gun in service in 1944 by a margin that left no room for optimism in Allied tank design discussions. The KWK 43 could penetrate 190mm of vertical steel plate at 100 meters. It could penetrate 153mm at 1,000 meters. It could penetrate 132mm at 2,000 meters. There was, in practical terms, no range at which a King Tiger's gun could not destroy any Allied tank it could see, and no range from which any standard Allied tank gun could penetrate the King Tiger's frontal armor. Allied commanders in 1944 who received intelligence reports on the King Tiger's specifications before the Battle of the Bulge were looking at numbers that had no comfortable response. The Sherman's 75mm gun could penetrate the King Tiger's side armor at approximately 100 meters under ideal conditions. The 76mm version could penetrate it at approximately 200 meters. Neither could engage the frontal armor at any combat range. The British 17-pounder, the most powerful Allied anti-tank gun in wide field service, could penetrate the King Tiger's hull front at under 200 meters with APDS ammunition, an engagement range that put the firing vehicle within easy range of the King Tiger's gun, while the King Tiger was at its most vulnerable for only a fraction of a second during the close approach. The M36. Jackson's 90mm M3 gun was the only American weapon that could penetrate the King Tiger's frontal armor from a distance, at which the engaging vehicle had a meaningful chance of surviving the King Tiger's return fire. The M36 had not been developed to solve this problem. It had been developed to solve a different problem entirely. The 90mm M3 gun began its existence not as an anti-armor weapon, but as a refinement of the 90mm M1 anti-aircraft gun that the United States Army had developed in the late 1930s to engage aircraft at high altitudes. The requirements for an anti-aircraft gun and the requirements for an anti-tank gun converge at a specific technical point: muzzle velocity. A projectile fired at a fast-moving aircraft must travel quickly enough to reach the aircraft's predicted position before the aircraft has moved too far from the fire control solution, which means the projectile needs to cover distance quickly. A projectile fired at armored steel must arrive at the target surface with enough kinetic energy to drive through the plate, which means the projectile needs to be moving fast when it arrives. Both requirements, approached from entirely different design problems, pointed toward the same solution: high muzzle velocity. The 90mm M1AA gun achieved a muzzle velocity of approximately 853 meters per second, with standard ammunition, high enough to reach aircraft at useful altitudes within the engagement window that fire control solutions could predict. When American ordnance engineers looked at the problem of fielding a gun capable of defeating German heavy armor in 1943, they found that the ballistic performance they needed, sufficient muzzle velocity to penetrate heavy plate at combat ranges, already existed in a weapon that had been designed for a completely different purpose. The M3 gun was the M1AA gun adapted for a vehicle mount, with modifications to the breech mechanism, recoil system, and carriage geometry that allowed it to function in the confined space of a tank destroyer turret. The ballistic performance was essentially unchanged. The same high muzzle velocity that let the M1 reach aircraft at 30,000 feet gave the M3 the kinetic energy to penetrate armor that no conventional tank gun of the period could address. This was not an original insight. German engineers had made the same connection between AA gun ballistics and anti-armor performance years earlier. The 88mm flat gun's legendary anti-tank capability during the Western Desert Campaign in 1941 and 1942 was a direct expression of the same principle. What the American 90mm represented was the belated American version of the same discovery, finally fielded in a vehicle-mounted form that could go where the armor went, rather than being limited to fixed or semi-fixed positions. The M36, carrying the 90mm M3, entered service with American armored forces in the European theater in the fall of 1944, arriving just in time for the German offensive in the Ardennes that would put it against the heaviest armor the Wehrmacht had committed to the Western Front. The HVAP round, hypervelocity armor piercing, designated T-33 for the 90mm, was the second component of the equation, and it represented a wartime metallurgical achievement that was as unlikely in its origins as the AA gun heritage of the weapon firing it. Standard armor-piercing projectiles in 1944 were made from hardened steel, dense, hard, and capable of penetrating armor by sheer kinetic force. The penetration of steel AP rounds against thick, sloped armor was limited by the tendency of the round to shatter or deflect when striking oblique surfaces at high impact angles. A round that would penetrate 100 millimeters of vertical plate might fail to penetrate 80 millimeters of plate angled at 45 degrees, because the obliquity caused it to break up or ricochet before it had driven through. HVAP rounds addressed this through a different approach. Rather than relying on a monolithic steel body, they used a sub-caliber tungsten carbide penetrator, a dense, extremely hard rod of tungsten inside a lightweight carrier body that discarded the carrier body after leaving the barrel and arrived at the target as a small, fast, dense penetrator rather than a full-caliber projectile. Tungsten's density, approximately 19.3 grams per cubic centimeter, compared to steel's 7.8, meant that a tungsten penetrator of a given size carried significantly more mass than a steel penetrator of the same size, which, at the same velocity, meant significantly more kinetic energy at the impact point. The T-33H VAP round fired from the M36's 90mm gun had a muzzle velocity of 1,021 meters per second and achieved penetration of approximately 220 millimeters of vertical armor at 100 meters, declining to approximately 179 millimeters at 500 meters and approximately 150 millimeters at 1,000 meters. Against the King Tiger's lower hull front, which was 150 millimeters at 50 degrees, producing an effective resistance of approximately 195 to 200 millimeters against HVAP at favorable impact angles, the T-33 at 500 meters was at the margin of penetration capability. At the margin meant sometimes yes and sometimes no, depending on the exact impact angle, the specific steel homogeneity of the plate, the precise velocity at the target after atmospheric drag had acted on the round, and the exact point of impact on the plate's surface. The margin was uncomfortable. It was also the only margin available. American armored unit commanders in December 1944, informed of the M36's capabilities against King Tiger armor, received a picture that was not reassuring, but was less catastrophic than what Sherman's and 76mm armed vehicles offered. The M36 could, under specific conditions, at specific ranges, from specific angles, kill a King Tiger. The Sherman, under essentially all conditions, at all practical ranges, from all angles except a very close-range broadside shot on the thinnest side armor, could not. The tactical doctrine that followed from this understanding was not complex. It was, in fact, almost identical to the doctrine that the M18 Hellcat's speed had enabled. Find the geometry that works, get into that geometry before the King Tiger knows you're there, fire from that geometry, and leave before the King Tiger can respond. For the M18, the geometry was the rear quadrant achieved through speed. For the M36, the geometry was the ambush, a fixed position chosen before the King Tiger arrived, at a range and angle where the 90mm M3 with T33 HVAP had a positive penetration probability, masked by terrain or structures that prevented the King Tiger's crew from locating the M36 until after the first shot had been fired. The engagements in the Ardennes between December 1944 and January 1945 that involved M36 Jacksons against King Tigers produced documentation that has been studied extensively because the encounters represent some of the few instances in the Western European theater where American ground weapons engaged the King Tiger in circumstances that produced reliable results. The pattern that emerges from after-action reports, German survivor accounts, and post-battle vehicle inspections is consistent with what the ballistic mathematics predicted and what the tactical doctrine had been designed to exploit. King Tigers engaged by M36s from frontal angles at distances beyond 500 meters were rarely destroyed by direct penetration. Rounds hit produced visible impact marks and sometimes structural damage to vision devices, cupola, or gun mantlet components, but did not achieve hole penetration in most documented cases at ranges beyond 500 meters from the front. The King Tiger's frontal armor held at typical combat distances when the engagement was frontal. King Tigers engaged by M36s from flank positions at distances up to 1,000 meters showed consistent penetration results. The King Tiger side armor was 80 millimeters vertical, entirely within the 90mm M3's standard AP penetration capability, let alone HVAP. An M36 positioned on the flank of a King Tiger was not fighting at the margin. It was firing a weapon with a positive penetration margin at any side engagement range that the anti-aircraft Heritage gun could reach. King Tigers engaged by M36s from any angle at ranges below 300 meters, including frontal engagements, showed the highest penetration rates, including cases where T33 HVAP rounds defeated the lower hull front plate, which was 150 millimeters at 50 degrees, but whose effective resistance at very close range and relatively favorable impact angles fell within the gun's capability. The ambush at Stavelot that opened this story was not unique. It was the pattern. Here is the first unexpected part of this story. Of the approximately 487 King Tigers produced and deployed, a number that has been refined by post-war German production records, the proportion destroyed in combat by direct enemy fire, as distinct from being abandoned by their crews due to mechanical failure, bogged down in terrain, destroyed by their own crews to prevent capture, or knocked out by air attack, is difficult to determine precisely and has been the subject of historical analysis that consistently produces a counterintuitive result. The King Tiger's most dangerous enemy in the Ardennes campaign was not the M36 Jackson. It was its own drivetrain. The Maybach HL-23OP30 engine that powered the King Tiger was the same engine used in the Panther, scaled to move a vehicle 24 tons heavier. The engine itself was not the primary problem. The final drive units, the gearboxes transmitting power from the engine to the tracks, were sized for the Panther's weight and had not been adequately upgraded for the King Tigers. Under combat loading on Belgium's winter roads, final drive failures occurred with a frequency that German unit commanders reported in terms that ranged from concern to despairing. Kampfgruppe Piper, the SS spearhead formation that included King Tigers and was tasked with reaching the Meuse River in the Ardennes offensive's first days, lost more of its armored vehicles to mechanical breakdown and fuel shortage than to enemy action during the advance phase. The King Tigers that reached La Glaise were, in several cases, immobilized by mechanical failure before American forces could engage them. Piper's surviving men escaped on foot, destroying their vehicles, including the King Tigers, before they left. The King Tiger, that could not be penetrated from the front by any Allied ground weapon in 1944, was frequently immobilized by a final drive failure that a competent mechanic with the right parts could have repaired in 4 to 6 hours. The parts and the mechanics were not available at the forward edge of a collapsing offensive in winter Belgium. a vehicle designed to be impenetrable to enemy fire, was frequently rendered useless by engineering limitations that the same designers who calculated its armor figures had not solved. The second unexpected part concerns the weight. The King Tiger, at 68.5 tons, could not cross most standard military bridges in the European theater without prior engineering assessment, and frequently required bridging equipment rated above the standard capacity of the combat engineer bridge sets that the Wehrmacht and later the Allies were fielding. The same engineering excellence that produced 185 millimeters of turret armor and an 88 millimeter gun that could destroy any Allied tank at any range had produced a vehicle that could be stopped by a river. German operational planning in the Ardennes specifically identified bridges as critical variables, not because the King Tiger was vulnerable to attack at crossing points, but because it was too heavy to use most of them. Routes of advance had to be selected partly on the basis of bridge capacity, limiting the King Tiger's operational flexibility in ways that its gun range and armor did not. American commanders who understood this limitation used it deliberately. The M36's tactical utility in the Ardennes was enhanced not just by its gun capability, but by its weight. Approximately 28 tons, less than half the King Tiger's, which allowed it to use terrain and road networks that denied the King Tiger approach routes. An M36 on the far side of a bridge the King Tiger could not cross had a tactical situation the King Tiger's crew could address with their gun, if they could find the M36, but could not address by maneuvering to a better position. The ambush geometry that the M36's tactical doctrine required was easier to establish and maintain when the vehicle being ambushed was too heavy to use half the available routes. The third unexpected part is about the open turret. The M36 Jackson, like the M18 Hellcat and M10 Wolverine before it, was fitted with an open-top turret, a design choice made to reduce weight and simplify production that was widely criticized by the crews who served in them. The open turret left crew members exposed to artillery fragments, small arms fire, and the Ardennes winter in ways that a closed turret would not have. The open turret also meant that a crew whose vehicle was hit had an exit path that did not require opening a hatch under fire conditions. The same opening that let artillery fragments in let crew members out, faster than any hatch mechanism, without the possibility of a jammed hatch or a dead commander blocking the exit. The M36's crew survival rate when the vehicle was struck and set on fire was significantly better than that of comparable German tank destroyer vehicles with closed turrets, a fact that showed up in casualty statistics, and that led experienced crews to view the open turret with something other than the straightforward disapproval that the cold weather encouraged. The liability was real. The compensating advantage was also real. In a vehicle whose tactical doctrine required positioning itself where it could be found and fired on, the ability to exit quickly was not a trivial consideration. The Battle of the Bulge numbers for M36 performance against King Tiger and other heavy armor have to be qualified by the limitations of the available records. German vehicle loss records from the Ardennes are incomplete, and distinguishing between vehicles destroyed by M36 fire, abandoned due to mechanical failure, and destroyed by their own crews is not always possible from the documentation that survived. What is documented clearly is the M36's role as the only American ground weapon the tank destroyer battalion commanders in the Ardennes assigned to anti-King Tiger missions with any expectation of a positive outcome. Shermans, including the 76mm variants, were not assigned to engage King Tigers from the front if M36 were available. The M36 was the dedicated solution to the King Tiger problem, however imperfect, and the tactical doctrine built around it, ambush positions, flank angles, HVAP ammunition reserved for heavy armor engagements, was the closest thing to a systematic response that American armored forces developed to a vehicle whose frontal armor had been designed to make systematic responses impossible. The deeper lesson of the M36 Jackson at the Battle of the Bulge was not about armored vehicle design or ammunition metallurgy or tactical doctrine, though all of those contributed to the story. It was about the specific way that a weapon designed for one problem becomes, through the specific physics it embodies, the solution to a completely different problem that nobody anticipated when it was designed. The 90mm M1 anti-aircraft gun was built to shoot down aircraft. The requirement that drove its muzzle velocity, getting a projectile to a fast-moving target at altitude before the target had moved out of the fire control solution, had nothing to do with tank armor. No one designing the M1AA gun in 1938 was thinking about 185mm of turret steel on a 68-ton German tank that did not yet exist. What they were thinking about was aircraft velocity and altitude and fire control mathematics. What they produced, as a consequence of solving that problem, was a gun with ballistic performance sufficient to address a tank armor problem that would not be defined for another 6 years. The anti-aircraft heritage of the 90mm M3 was not an accident of history. It was the specific mechanism by which the physics requirements of one military problem, shoot down fast aircraft, produced a weapon capable of addressing a completely different military problem, penetrate the heaviest tank armor fielded in 1944. The King Tiger had been designed by engineers who knew exactly what guns existed, and exactly what performance those guns achieved, and who had armored their vehicle to defeat all of them. They had not fully priced in an anti-aircraft gun on a tank destroyer. The M36 Jackson at 400 meters outside Stavelot, with a T-33 HVAP round loaded, and a crew that had chosen the farmhouse for its masking geometry, had found the geometry where an AA gun on a 28-ton carriage was exactly sufficient. 4 seconds. One King Tiger. And a design lineage that had never been intended for either of them.